Thank you for coming here. I'm Dongmin Kim. Today I will talk about the impact of the Madden-Julian oscillation on the subseasonal US tornado activity and the underlying physical mechanism. And this study collaborated with the Sangiri and Hosmeropet. And why is the tornado forecast important? Look at this chart. X-axis is kind of the extreme weather event, and y-axis is number of the fatalities. So according to the U.S. National Hazard Statistical Report, the tornado is one of the top 3 most hazardous weather events in the U.S. So actually, NOAA Storm Prediction Center provides 7-day lead times of tornado forecast based on the probability of the convective outlook. However, this 7-day lead time is not enough to prepare the resource to save the lives and protect the infrastructure. So, with the can we predict the U.S. tornado activity at more longer lead time, so such as subseasonal to seasonal timescale? So I will show you the typical relationship between the forecast scale and time. In the weather timescale, the atmospheric initial condition is very important. So this forecast scale is dramatically decreasing by time because of the atmospheric memory is very short. And in the subseasonal time scale, many studies suggest the land condition is important to predict. And in case of the subseasonal time scale, ocean condition, which is persistent variable such as SST, is relatively important to predict the climate variability in the subseasonal time scale. So this subseasonal and seasonal time scale is defined by S2S forecast, which is very hot issue in our field. So let's think about the tornado forecast system. So SPC has a convective outlook in the weather time scale, and in the seasonal time scale, we have the experimental, the seasonal severe weather outlook, which is ongoing project at AOML. However, in the subseasonal time scale, there is nothing to predict the U.S. tornado activity. So we also think, is it possible to predict the tornado activity in this time scale? So we try to find out some potential predictor in this time scale. So that was MGO. So actually MGO is the convective anomaly over the maritime continent, and this convection anomaly is propagated eastward along the equator with 30 to 90 days period. So look at this figure. This convection is developed over the Indian Ocean area, and it propagates eastward. And this is a very periodic phenomenon. Actually, and NOAA CPC provide 14 days the MGO forecast based on the RMM index. So, for instance, MGO page 2, it means that when convection is occurred over the convex center is occurred over this Indian Ocean area, and the other studies suggest the GFS hydrocast also have a good skipper MGO forecast with a month's lead time in like this figure. So from these results, MGO could be one of the possible and potential predictor for the U.S. tornado activity in the subseasonal time scale. So we checked some relationship. There has been some relationship between the MGO and U.S. tornado activity in this year. So look at this figure. X-axis is time, and y-axis is daily number of the tornado. So, and bold flag line indicate the accumulate the tornado count in climatology, and red peaks is daily tornado activity. So we found the 4 extreme tornado case in this year. So at first case is March 4th. At that time, 23 people died in Alabama state. At this time, the MGO page was poor. And second event was middle of the April. At this time, 8 people died in the Alabama, and Georgia State. At this time, also MGO phase 4. And third case is the end of the April. At this time, 36 tornadoes are reported over the only central US. At this time, MGO phase was 5. And last event was last month. At that time, the 48 tornadoes are reported over the central US. At this time, MGO phase A. So from this result, when 3 of the extreme tornado events occurred during the MGO phase 4 or 5. So look at this result. There has some relationship between the MGO and US tornado activity. So we reviewed some previous study. So a lot of the previous studies suggest that MGO and US tornado have some relationship, and there has some significant signal, but the relationship between the MGO and US tornado activity is significantly depending on the metric of the tornado activity and then target month. For instance, the Thompson and Rowdy suggest that during the March, April, and May, at that time, highest tornado activity is during the MGO phase 2. On the other hand, Barrett and Jensen suggest the highest tornado activity is during the MGO phase 6 and 8 in the April. However, in the May, the highest tornado activity is during the MGO phase 5. So that has a month-to-month variation. So based on this statistical result, Barrett et al. Demonstrate that there has some good forecast skill for the propagation of the tornadic environment associated with MGO, such as cave, like this one. So look at this figure, MGO phase 4 and 5, 6, 7. At that time, over the Great Plain area, there has a more positive cave condition, and it has a good periodic event. So from this previous study, there has a MGO and US tornado have some relationship, and that has some significant. However, they didn't mention some mechanism why MGO modulate the US tornado activity. So today, my main objective of this study is to examine some physical mechanism of the relationship between the MGO and US tornado activity, and we further demonstrate our new hypothesis using the linear Barclay model with idealized diabatic forcing. So this our new hypothesis I will talk later. So this is the data method I use. For tornado analysis, I use the NOAA SCP data, and for robust result, I only use the strong tornado case, which is reported to Fujita and enhanced Fujita scale greater than 1. And to examine the spatial distribution of the US tornado activity, so I count the tornado genesis into the 1-by-1 grid point. And for MGO, yeah.
In the first line, you say greater than 1, and in the second line, you say you're counting 1 through 5. So are you using 1, or is those separate data sets?
No, same. So greater than 1 to 5 is 5 is the maximum.
Yeah. Right. So greater than 1 means you're using 2 to 5.
Yeah.
Greater than or equal to 1 means 1 to 5. Are you using 1 or
using 1
or 1 to 5?
Using 1.
Okay.
Yeah. Okay. So equal to 1. Yeah. And so for MGO analysis, I use the NOAA interpolated outgoing long-wave radiation and wind at upper level and low level and mid level geopotential height from the NCF2 analysis data, and to demonstrate the relationship between MGO and
that season of MGO and the tornado season are same, or MGO is throughout the year, it is only affecting during the tornado season?
I will talk later. Yeah, that is some result. Actually, MGO has some seasonality, so I will talk that detail. Yeah. So to demonstrate the relationship between the MGO and then tornado environment, such as the cave and low-level wind shear. I use the North American regional analysis data. And real-time multivariative index is used for the MGO index. So this RMM index is very famous and commonly used for the MGO study. So for robust result, I only use the strong MGO case. And here is the result. This is the spatial distribution of the tornado genesis. And the maximum number of the US tornado genesis is over the South US. And this location of the US tornado genesis is migrate northward by time and become broader with season. So this spatial and temporal variation of the US tornado genesis may contribute to limited the tornado forecast scale. And this is the result from the MGO analysis. And in this, the left figure shows the x-axis is the longitude and y-axis is normalized variable. And black line indicate the weather anomaly, and green line indicate upper level zonal wind, and red line indicate the low level zonal wind. So in the EOF1, the convection center is located over the maritime continental area, and this center is propagate eastward to the Western Pacific warm region. So these two structure of the eigenvector in the combined EOF is very constant with the other previous MGO study. And this is the composite map of the weather anomaly at each MGO phase, page 1 to 8. So you can find that when the convection is developed over the Indian Ocean area and it is propagated eastward, and you should note that when the convection is located in the maritime continent and Western Pacific warm region, at that time, the compensating subsidence occurred over this eastern tropical Pacific. So this zonal contrast is very important in our hypothesis.
What is the criteria to divide to different phases of MGO?
This day, so like this one. Like this one, RMM2. This is combined by the RMM index. This is the PC time series of the EOF1 and 2. So when you combine this PC time series, at that time we can get the MGO page. So I just grip some composite map of this. When they put in this page 2, at that time I just grip all of the anomaly in this data. And so let's think about the relationship between the MGO and US tornado activity. And this is the seasonal cycle of the tornado genesis associated with the MGO. And x-axis is the month and y-axis is the MGO phase. So you can find that during the early boreal spring, such as March and April, at that time, the relationship between the MGO and US tornado genesis is very complicated. So for instance, MGO page 2, at that time, the US tornado genesis is enhanced in the March. However, in April, the signal is opposite. So during the dead season, the relationship is very complicated. However, on the other hand, during the latest boreal spring and the early summer, such as May, June, July, at this time, the relationship between MGO and US tornado genesis is very robust compared to the other season. So in MJJ, US tornado genesis is enhanced during the MGO pages 3, 4, 5, 6, as we call the active phase. And on the other hand, the US tornado genesis is suppressed over the during the MGO page 1, 2, and 7, 8. So so as we call the inactive phase. So this MJJ is my target season. At this time, tornado is also activated, and then MGO has a have a robust seasonal characteristic. And this is the special distribution of the tornado genesis in the MJJ. So the maximum US tornado genesis is occurred over the South US, as we call the tornado alley. And this figure B indicates the peak MGO phase of the tornado genesis over the US. So you can find that the peak MGO phase for the tornado genesis is during the MGO phase 3, 4, and 5, 6, which is colored by the red and green color. So at this time, the convection is MGO convection is located over the maritime continent and Western Pacific warmful area. So from this result, MGO modulate the US tornado activity in space. So why it happened? So we investigate the MGO induced the large scale atmospheric circulation associated with MGO. So in this shading indicate the oil anomaly, and vector indicate the upper level divergence wind. So during the inactive phase, strong positive oil anomaly occur over the maritime continent and upper level convergence. So to compensate this motion over the Eastern Pacific area, there has more convection and upper level divergence. Conversely, during the active phase, at this time, the spatial distribution is nearly opposite. So more convection over the maritime continent area and upper level divergence occurred. And then over the Eastern Pacific area, there has a more anomalous subsidence with the upper level convergence. So how about the middle level and low level atmospheric circulation? And in this figure, shading indicates the geopotential height anomaly at 500 hectopascal, and vector indicate the low level wind anomaly. So during the inactive phase, at that time, the low level westerly anomaly dominate over this central tropical Pacific, and then this low-high-low pattern occur over the Pacific and North America. So this anomalous trough over the South US area, that is the induced the northerly wind anomaly, and this northerly wind anomaly suppressed the North American low-level jet. Conversely, during the active phase, at that time, over the Central Tropical Pacific, there has a easterly anomaly, and this high-low-high pattern is occurred over the Pacific and North America. So this atmospheric ridge induced the southerly wind anomaly, and this southerly wind anomaly enhanced the low-level jet. So this low-level jet is a very important factor to modulate the US tornado activity. So now we investigate some relationship between the MGO and tornadic environmental parameters such as cave and low-level wind shear. So in the upper figure, the shading indicates the low-level wind shear, and the vector indicates the low-level wind. And in bottom figure, shading indicates the cave, and vector indicates the vertical integrated water vapor flux. So the color from this color is the more unfavorable condition for the US tornado genesis, and this color indicates more favorable condition for the US tornado genesis. So during the inactive phase, at that time, the northerly wind anomaly is dominant over the US area, and conversely, during the active phase, at the time, southerly wind anomaly over the US area. So this southerly wind anomaly bring the more warm and moist air from the Gulf of Mexico into the US area. So it makes the thermally instability, and this low level wind shear also make the more mechanically instability over the US. Okay.
I thought on a previous slide you showed the 850 millibar wind anomaly.
Yeah.
And I think it was the opposite of that. Can you go back? Yeah, that one. You have the top one is when you have more tornadoes in the U.S., right? Or is it less?
No. The top one is the less.
Top one is less.
Yes,
oh,
yeah, okay. Yeah. So MGO 3, 4, 5, 6 is more tornado.
Okay.
Yeah. So this enhance the low level jet make the more instability in thermally and mechanically. So that condition make the more positive phase of the low level wind shear and cave. So it make the more tornado genesis over US. And interestingly, we found something new, and so we found the two clusters of the US tornado genesis during the active phase, page 3, 4, 5, 6. So during the MGO page 3 and 4, at that time, US tornado genesis is more frequent over the South US. And however, during the MGO phase 5 or 6, the US tornado genesis more occurred over the eastern part of the US. So this is maybe, we just think of it, this is maybe the MGO page 3 and 4 and 5, 6 make a different tornado environment condition in space. So it affect the US tornado genesis in different area. So this is the result. So during the MGO page 3 and 4, at that time, low level jet is enhanced over the Great Plain area, and it's more straight. However, during the MGO page 5 or 6, at that time, the low level wind shear is shifted eastward. So it has a more southwesterly wind anomaly. So this different low level jet is induced the different tornadic condition over the US in space. So that make the difference of the US tornado genesis in space. So, however, many previous studies told and suggest the MGO can affect the US climate variability and weather variability during the only boreal winter because of the like this. So when this is DJF. So when the convection is occurred the maritime continent, at that time it has some loss wave propagation, and this modulate the atmospheric circulation over the US. However, our target season is MJJ. It is more the summer season. So at that time, the jet stream is very weaker and more forward side shifted. So we thought there has the other mechanism. So this is the composite map of the weather anomaly during the MGO phase 3, 4, 5, 6, which is active phase. At that time, diabatic heating occurred over this maritime continent area, and diabatic cooling occurred over the Eastern Pacific area. So our hypothesis is that diabatic cooling over the Eastern Pacific area is more important factor and more main driver to modulate the atmospheric circulation over the US. So to demonstrate our hypothesis, we used the linear baroclonic model. And this LBM has a T21 horizontal resolution. It is approximately 5.5 degree resolution. and then it has also 5 vertical sigma level. And basic state is MJJ average for the 38 years obtained from the NCEP2 analysis data. And this is the diabetic pulsing, special distribution of the diabetic pulsing, and this is the vertical profile of the digit2 center of the diabetic pulsing area. So I did the 3 LBM experiment. First one is the all pulsing simulation, which is the pulsed by both of this diabetic pulsing over the maritime continent and Eastern Pacific area. And the other 2 scientific test is for the which diabetic pulsing is more important to modulate the atmospheric condition in the US area. So MC pulsing experiment is only pulsed by the diabetic heating over the maritime continent area, and EP pulsing experiment is only pulsed by this diabetic cooling over the Eastern Pacific area. And this is a repeated figure, and shading is the geopotential height at 500 hectopascal, and contour is to indicate the oil anomaly during the MGO phase, MGO active phase. So you can find this high, low, high pattern is very well shown in this NCEP2 analysis data. And this pattern looks like a negative PNL-like pattern. And then in the all pulsing simulation, the spatial distribution is very similar to the NCEP2 analysis data, except for this weakening of the anticyclonic over the North Pacific. But spatial distribution is very well simulated in the LBM. So from this result, it means that the digit2 pulsing is main driver to modulate this global atmospheric circulation, and also LBM is very well reproduced this MGO modulation, MGO induced atmospheric circulation. So especially in this North and Central America, this meridional contrast of this geopotential height is very well simulated in the LBM simulation. So let's move to the sensitivity test. In the MC pulsing simulation, this low-high-low pattern, meridional low-high-low pattern is occurred, and then this pattern is very, very similar and consistent with the Wang and Wu previous study. And the impact of this diabetic heating over the maritime continent on the atmospheric circulation over the North America is very weak, nearly zero. However, despite of the weaker diabetic cooling over the Eastern Pacific area, this overall spatial distribution of the geopotential height is very similar compared to the other pulsing. So, and this atmospheric ridge is caused by this Gill-type response. So, from this sensitivity test, the EP diabetic cooling is the main driver for the MGO-induced atmospheric circulation over the North America in MJJ season. So this is the example of the Gill-type response. In the symmetric case, at the time when the diabetic heating occurred the equator, at the time it generates a pair of the cyclonic circulation in both hemispheres. On the other hand, when the diabetic cooling occurred the equator, at the time it generates a pair of the anticyclonic circulation in both hemispheres. However, how about in asymmetric pulsing case? So the off-equatorial diabetic cooling, it generates a single anticyclonic circulation in the forward side of the pulsing region. So this looks like the EP pulsing simulation over the North America. So it means that this diverting cooling over the Eastern Pacific region, it generates the anomalous reach over the South US area and enhance the more southerly wind anomaly. So summary and discussion. During the MGO active phase, during MGO phase 3, 4, 5, 6, at the time, the more convection motion occurred over the maritime continental area, and it generates the diverting warming and upper level divergence, and then this to compensate this upper level divergence, it generates over the Eastern Pacific area that has upper level convergence, and this upper level convergence induced the anomalous subsidence and diverting cooling, and so this diverting cooling generates the geothermal response. So this geothermal response generates this anomalous reach over the South US area. So this anticyclone circulation enhances the low-level jet over the US area. So it increasing enhances the low-level jet, increasing the instability of the atmosphere. So that generates more tornado in the US during the MGO active season. This is next plan. So I will develop the tornado forecast system based on the MGO index using the statistical method. So if it's done at the time, we can predict the US tornado activity in the subseasonal time scale. Yeah, that is my hope. I'm not sure we will do that. Okay, reference, and thank you for attention.